So the other one that you would have met at GCSE is covalent bonding. This is always between two non-metals. So again, you look at your periodic table, if they're in the top right-hand corner, or it's hydrogen as well, you're looking at it being covalently bonded. So always check what it is, and that counts for A2 as well, because the number of times you'll come for A2 and someone will say it's ionically bonded when it's two non-metals. So always check your periodic table. Generally, they only want very simple ones at AS. So, and the key difference is the electrons are shared between two atoms. So in ionic bonding, it's a complete transfer. In covalent bonding, they're shared. So the simplest example would be two hydrogen atoms coming together. So those are my two hydrogen atoms. They both want two electrons, so they join up by sharing those two electrons, like so. What's the advantage of that in terms of, well, at the moment that electron is only attracted by that nucleus, but now he gets attracted by that nucleus and that nucleus. Yeah, so you get more of an attraction. So equally for that guy as well, he's now got, obviously they are orbiting around, but he's still got two nuclei to be attracted to. So that's the simplest case. So that would be a single covalent bond, and you draw that, as you know, by just putting a line between them, like so. You get slightly more complicated examples. So if we were to do oxygen, and again, I'll only do the outermost shell. Oxygen.
6?
Yeah, 1, 2, 3, 4, 5, like so. So 6 electrons. So they want to gain 2.
Yeah.
So how would they do it? They form a double covalent bond.
Double, okay.
So I've got 1, 2, 3, 4. 1, 2, 3, 4. But these two go in, and these two go in. So if I count up around each oxygen, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So they both got 8 electrons. And then you can get triple bonds for nitrogen as well. The other one, carbon dioxide, is one that people need to watch out for. Carbon dioxide has double bonds, but he's also got lone pairs on the oxygen as well, because oxygen's got 6, as we just done. So 1, 2, 3, 4, 5, 6. Well, we're keeping them as being circles, like so. So to draw double bonds, you put a double crazy, double line, like so. You've got to be able to do your dot and cross diagram before you can move on to the next stage. So the other one is dative covalent bonding.
Yeah.
So in dative covalent bonding, the electron pair comes from one atom.
And the other one is like a ion or something, you just join them.
Yeah, the two electrons come from one atom. So the simplest example would be ammonia. Ammonia, I won't know, is this guy. But nitrogen has got a lone pair. He meets H+. H+
Has no electrons.
has got electrons. So he comes and sits on that lone pair. So we get a dative covalent bond.
The ammonium.
Brilliant, yeah, like so. H, 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 and then in big square brackets.
Is that because it's an ionic?
Yeah, it's an ion. So we're going to put square brackets and put the charge, because the charge is on the whole.
Why is it ionic?
Well, it's an ion. because it's got a charge on him now. Because I've got an H plus meeting a neutral molecule.
Okay.
So overall he's got a, so he's just put it in square
Even though,
brackets.
so you can have an ionic compound without it being ionically bonded.
Yeah, that's good. Yeah, he's covalently bonded, but he's got a charge. So very similar, although he can go into it. Sulfate is actually covalently bonded because I've got two non-metals.
So it's
But overall they've got a charge.
So its charge is different from the way it's bonded.
Yeah, if I could then have an ionic bond. So if I then had ammonium chloride, which is meeting Cl minus, like so. Like so. That is an ionic bond between the ammonium and the chloride, but I've got covalent bonding in the ammonium ion.
Why is it bonded how they're spare electrons?
He had a positive charge. So I can't just create an H plus from somewhere. So this H plus must have come from maybe hydrochloric acid. So with him, he would have had a Cl. Like so. So I've added that,
Oh, so
that,
the
and
electron
that.
from the hydrogen has gone to the chloride.
Yeah, that's right. So that's my ionic bond.
Okay.
Yeah, in the hydrochloric acid.
That's
That's
that.
gone. They then met him. He's said, "Oh, hey, I'm going to join you." But the chloride is still, because the positive charge is now spread over the whole molecule, he's still around. I could never give you a pot of hydrogen ions. It would always come with a negative ion as well, and then you just
So
open
it's
up.
just attraction between the minus and the plus ions at the end.
That is the ionic bond. Holding this ammonium together are covalent bonds. So holding this thing together is a covalent bond, but holding this together is an ionic bond.
How is the ionic bond created? There's,
Okay, so I have my ionic bond here.
yeah, I get that.
Okay, all he's done is he's moved over to that guy, so now the ionic bond is between that and that. So it's just spread it out. So he's kind of those two are attracted together.
Because it's plus and minus.
Yeah. He at the moment isn't interested because he's neutral. But hydrogen ion comes along and says, there's a lone pair of electrons.
Yeah,
of
so
ion.
that becomes a plus.
So that whole thing now becomes a plus charge here. So he is now attracted to the whole of the plus charge.
So is it just attraction?
Yeah, just here.
So that's what I was